Okay, AP Calculus AB, Unit 1, Exam Corrective. This is to get you ready for the retest. You should have seen your test, original test, figured out what mistakes you're making, looked at the solutions, then try this corrective as if it's the test again, check your answers, and then this video will help you figure out what you're doing wrong or the work you're not showing that you need to. This, has pretty good representation of the same problems that were from the test. But if there was a type of problem that was on the test that's not on here, it's still fair game on the retest. So we got to turn decimals into ratios, rational numbers. So if as a repeating decimal, usually I call it n, you're going to multiply by 10 to the power of the number of repeating spots. So that would be 100. So you're going to multiply both sides by 100. So you're going to have 100n equals 36.36. The repeating part, you're going to subtract n from both sides. It should line perfectly up the repeating parts so they cancel out. You might have some decimals left over. If these don't line up right, then something's wrong. Okay, so we're going to get 99n equals 36. I'm going to divide both sides by 99. And I'm fine with that being your final answer on the test. You could reduce it if you'd like. Take a 3 out of both of those. It'd be 12 over 33. We could take another 3. It'd be 4 over 11. But I'm okay with 36 over 99, so you might just take that. This is going to be equal to n. We're going to multiply by 10 to the first power, both sides, right? So it's going to be 10n equals 3.6. Now, you could put the repeating bar there. The 3 is not part of the repeating, so don't put 3636. But when you go to subtract n, you want the repeating part of the original n to cancel out with something here. So what I'm going to do is I'm going to put one more 6 and put the repeating part there so that the repeating parts cancel each other out. So 9n equals 3.3. Then you can divide both sides by 9. Now I'm not okay with 3.3 over 9 as a final answer because decimals in fractions are bad form. So if anything, you multiply top and bottom by 10, change it to that, that's okay for your final answer. Or you could say, you could take a 3 out and be 11 over 30. That's fine. This one, please don't make it harder than it is. There is no repeating part. So it's just 36/10ths, and you're done. Or if you like, you could reduce it. You could take a 2 out, another 2 out. That's fine. Okay. True or false? I need you to support your answer. This one, you can very clearly support it by doing the same trick that we just did. N equals 2.9. 10n equals 29.9. Repeating, we're going to subtract n. 9n equals 27. Divide both sides by 9. N equals 3. So 2.9 repeating is actually equal to 3, which I feel like doesn't make that much sense at first if you think about it. So we're going to replace 2.9 repeating with 3 and show that it is true. So part of it's to figure out what 2.9 repeating is as a ratio of integers, and then to plug it into what you have and show it's true. Now, this has a pattern. Some of you are like, well, so is it rational? No, it's not. Now be careful. In the test, I think we might have said irrational, which means not rational, which it is not rational. So you gotta be careful. So this is false. It's not rational. I wouldn't say that it doesn't have a pattern. There is a pattern, but it isn't It's, when it's not the same set of repeating digits or something like that. And there's a pattern. I could predict that the next thing is probably going to be this because there's a pattern. That doesn't mean it's a repeating decimal, though. So we'll say false. Okay. All right, next ones. You should get 100% on the section on 3A, B, C, D, but a lot of you lost a lot of points. I find drawing pictures to be helpful. So this is a solid circle at -4, greater than or equal to. I'm going to write the other one right below it or on the same line. It's an open circle at 1 and an arrow to the left. The word is and, which is the same as union. No, actually, it's the same as intersection. So it's where they overlap. So it's true for both. At -4, it is not true both for 1. It is true both for everything in between. So your final answer is going to be -4 to 1. Bracket parentheses. You can lose a little bit of points for getting the bracket parentheses wrong, but it adds up. Now, we're essentially doing the same problem, but with the word or. But I find it helpful to draw pictures. Now, or means either one can be true. So wherever at least one of them is true, which is the whole number line. Any point in the number line, one of these is true. You don't put a hole here. It's true on this one. So we would say, well, it's all real numbers, which is not the answer I want because that is not interval form. Interval form would be -infinity to +infinity. Parentheses, always on the infinities. Okay, next one. Solid dot -3, open dot 1. The other one is a open dot at 0, and then to the right forever. And it's at intersection, so that means they both have to be true. It's the same as and, so it's going to be 0 to 1. So your answer is 0 to 1, parentheses. That's it. Okay, next one. Solid dot 2, arrow to the left. Open dot -2, arrow to the right, arrow to the left also. Be careful, make sure you look closely and don't just assume. And they both have to be true, which is over here. So that's going to be -infinity to -2. So you don't necessarily have to draw the final answer. You could kind of look at what you have there. So we need to get those 100%. That should be, you should love those problems and want as many as possible. Now, number 4, A, B, C, D. This is a little different question. Which of the following are always correct, meaning true, when A is greater than B, but A cannot be equal to 0? Now, some of these you could do a little math and say, well, if A is greater than B, then A is greater than B is always true, right? And you're showing some work. This one here, we can subtract 2 from both sides. We could divide both sides by -1, which would require you to flip the symbol. And sure enough, that is always true. This one, we could divide both sides by a squared. Now, we can do this and not worry about the direction of the inequality because a squared is positive. When you divide both sides of the inequality by negative, then you would have to flip the symbol. And if you don't know what a is, well, this does say a is greater than b, but that doesn't mean it's positive. So you got to watch out. Now, this is greater than or equal to. So if a is greater than b, wouldn't a be greater than or equal to b be true? Yes. I don't think they're going to be equal, but this will be true as long as that's true. If this is true, then this is true. So the answer is true. And this one we could add b to both sides. So we say b is less than a, which is the same as a is greater than b, which is true. So there we go. Okay, solving inequalities. Now, this is an easy linear one, so we don't need to do a number line. You could move everything on the side equals 0, and that should work. It's just a little, I think you've made it harder than it needs to be. This is linear inequality. You just solve for x. Now, we do have to flip this symbol because we're just divided by negative, and then usually go like this. Now, interval notation, that's going to be negative infinity to negative 6, parenthesis, bracket. You could draw a picture if you want to help. Like I said, you could move everything on one side equals 0. So we could let's bring these over here. You could say 2x plus 12 is less than or equal to 0, and you could factor it, find the zeros, and do a line check. You could do a line check. It's a solid dot, negative 6. You could test. I like to test far right. 0 just seems easy. That's false, true. Same answer. But, I don't know, that seemed pretty easy. Okay, here, we want to get x by itself in the middle. Whatever you do in the middle, you got to do the left and the right. Some of you guys want doing it to the right side, for instance, or you want to distribute it to everything. Now, we did just divide all sides by negative, so that's going to flip those. So we still have 2x minus 5. So then we're doing reverse order of operations is the best call when you're solving equations. So we're going to add 5 to the middle, left, and the right. You divide by 2, little left and right. So this is your answer, but I need an interval notation. So you could say 7 halves, comma 15 halves. And there's going to be brackets. You can write 3.5 and 7.5 if you like. It's up to you. Now, x equals 0. Some of you guys are missing that root on some of the problems that had just x as a root. X equals negative 3, but watch out. It's being raised to an even power. This is going to be, if you're to solve this, you would say, oh, well, x could be plus or minus 3, right? A lot of people were missing 2. They were only giving me one of these. It's both of them. So we're going to put these in a line. Everything on the top is going to be a solid circle because the or equals to. Everything on the bottom is going to be open circle because it's division by 0. Left to right. So we have a negative 3. Oh, and check this out. Ooh, this is interesting. X equals negative 3 on the top, right? And x equals negative 3 on the bottom. Well, that's the same as like a double root, except there's 2 of them here and 1 of them here. So that's like 3 of them. So if you get them on the top and the bottom, then you kind of like count them all together. So actually, we're not going to have that bounce off the graph at x equals negative 3 after all. It's got to be an open dot, though, because bottoming creates a division by 0. So the bottom wins out on that. We're going to have a solid dot at 0 on the top, and then another open dot, positive 3 on the bottom. We test far right. You guys need to write down what you're testing. Some of you guys aren't writing down your testing, or it's unclear. Write the word test and write it near where you're testing and tell me the value. So if I plug 4 in here, it's positive, positive, negative, which is true, false, true, false. So the answer is negative 3 to 0, parenthesis bracket, union, 3 to positive infinity. So that problem's kind of handed to you as it had that little weird situation that I don't think we've talked about, but that's how it works. If you get the same root on the top and bottom, it's like adds up the count. Now this one, I'm going to move everything to one side compared to 0. Then you want to try to factor it. So, we try 6x and x. And you should keep this inequality coming on every step of the work. So we need to get a negative 1 in the middle. So if we do like 3 here and 4 here, nope. 4 here and 3 here, nope. 2 and 6. If you do 6 here and 2 here, nope. 1 and 12. No, so I think we got to try 3x and 2x. So then if I do 12 and 1 here, nope. 3 and 4, 3 and 4. Ooh, I think that's it. 3 here, 4 here. You need a negative, so it's going to be negative 8x. No. Negative 9x plus 8x. Check your answer. Refill it out. See if you get what you start with. So x equals negative 4/3 and x equals 3/2. So we're going to do number line. There's going to be solid circles. Tell me what you're testing. X equals 2. Positive, positive. True, false, true. Negative infinity, negative 4/3. Bracket, union, 3/2. Positive infinity, parentheses. There you go. All right, let's keep it going. X cubed plus 4x squared minus 9x minus 36 greater than or equal to 0. We could try grouping. If it's in standard form and it's even number of terms, GCF of the first pair, GCF of the next pair would be a negative 9, x plus 4. If you get the same thing inside both parentheses, grouping works. It's worth it. Usually it doesn't work, but if it works like every once out of 10 times, I think it's worth just considering. So factor what's left, x plus 3, x minus 3. So that's fully factored. Our roots are negative 4, negative 3, positive 3. So these are all solid circles. Test, tell me what you're testing. Far right. I like to test far right. 4. Positive, 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 positive. True, false, true, false. Negative 4 to negative 3. Brackets. Union 3 to positive infinity. Okay. Now you could do rational root theorem on that, which I have to do in the next problem. So you should now do rational root theorem. X cubed plus 6x squared minus 32 less than 0. This is not a quadratic, it's a cubic. We can do grouping for sure because it's an odd number of terms. So we're going to try rational root theorem. So P over Q, we've got to come up with a list. So the P's come from here, the Q's come from here. So plus or minus 1 over plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32. I think that's the exhaustive list. Hopefully it's one of these nice small numbers from the beginning. So check it. If you plug 1 in here, you get 7. Nope. Negative 1. Nope. 2 would be 8 plus 24 is 32. It's positive 2. So now we're going to use synthetic division with positive 2. Now positive 2 is going to give you an x minus 2 in the next step. This doesn't just disappear. We're dividing x minus 2 out, and then that's what factoring is, division. It's unmultiplying. We need a 1, 6, 0 for the missing term, negative 32. Drop the first term down, right? 2 add 16 add 32. You should get a 0 at the end, otherwise you picked the wrong one or messed up or forgot a 0. Something's wrong. Now, we have an x minus 2 because of this guy, right? And now we have an x squared plus 8x plus 16. And we should still have less than 0. Now this we should be able to factor. And if we can't factor it, that means it doesn't have a rational root. And the rational root theorem is not going to help you. So you could do quadratic formula if you can't figure out how to factor it, even if it is factorable. Now that's a repeated root there, which I find helpful to write as a power so you don't forget. So x equals 2, x equals negative 4, but that's a little star there. So these are all open dots. I'm going to test x equals 3. Which is going to be positive, 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 which is false. Oh, let's not forget this. I almost forgot it. False, true, true. Now here's the deal. We have to break it up here because it's open dot. If it's a solid dot, I wouldn't break it up. But we got to break it up. Negative infinity, negative 4, parenthesis, union, negative 4 to 2, parentheses. You got to break it up because it's an open dot. If it's solid dot, don't break it up. All right, let's take a look at the back. Now, there are a couple graphing calculus problems at the bottom, but that's fine. They're not going to be graphing calculus problems on this part of the test, on the retest. So, but it's good practice for the other part of the test. So we get some rational inequalities. So everything has to be moved to one side. Okay, we got to combine it into a single fraction. So you got to give least common denominator. So you got to multiply the top and bottom of this one by x plus 2, which I feel comfortable doing in my head, but if you need to. And top on this one by x plus 3. And don't forget to distribute the negative at the same time if possible. So this gets distributed x squared plus 2x minus 2x minus 6. Don't multiply the bottom out. It's already factored for you. If you multiply the bottom out, you're just going to undo it in the next step. Do work, undo it. Now, so on the top, we could think it was a difference of squares, x plus root 6, x minus root 6. Or you could do quadratic formula, or you could solve it. I mean, there's 3 different ways you could get these. So we're going to have x equals negative 2, x equals negative 3, x equals positive root 6, x equals negative root 6. Number line, the tops are going to be solid dots. Now, root 6 is between 4 and 9. It's closer to 4. So it's between 2 and 3. So, I mean, I would guess like 2.3 or something like that, 2.3, 2.4, which I think is close enough to make sure you get in the right spot for your number line. So, negative 3, then negative root 6, then negative 2, and positive root 6. I'm going to test a value. X equals 3, which I think is maybe easier to look here. 9 minus 6 is positive, 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 true, false, true, false, true. Final answer, negative 15, negative 3, parentheses, union bracket negative root 6 to negative 2, parentheses, union bracket root 6 to positive infinity, parentheses. There you go. All right, got another one. Move everything to one side, compared to 0. Give them least common denominators, so that's going to get multiplied by x plus 6, top and bottom. Then you got to distribute it. This one's going to get multiplied by 3x plus 4. And you got to distribute this. I do the negative 2 at the same time. So we're going to get x squared plus 6x minus 6x minus 8. On the bottom, you have x plus 6, 3x plus 4. Leave it factored. Top, simplify. X plus square root of 8. X minus square root of 8. Now, so on the top, I'm going to get x squared of 8, which is 2 root 2 simplified. Here you get negative 2 root 2. X equals negative 6. X equals negative 4/3. Now, 2 root 2, I think it's easier to estimate the square root before you simplify it. The square root of 8 is between 4 and 9. It's much closer to 9. It's probably like 2.9 or 2.8 or something. Write this in your work, your estimate. Don't write it in your answer. So, negative 6 is open dot. Negative 2 root 2 would be next, solid dot. Negative 4/3, open dot, and then positive 2 root 2, solid dot. Test a value. 3, positive, 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 true, false, true, false, true. The answer is negative 50, negative 6, parentheses, union, bracket, negative 2 root 2, negative 4/3, parentheses, union, bracket 2 root 2, to positive infinity. There you go. Let's get really good at this stuff. Okay, we got some absolute value problems. Don't square both sides of this unless you like making the problem way harder than it has to be. I mean, it should give you the right answer. There's 4 situations. It really boils down to 2 for this. Inside equals inside, negative of the inside equals the negative inside. Well, it's the same case. And then inside of 1 equals the negative of the other inside, or vice versa. This equals the negative of that. Well, that's just the same case. So then we just solve these. So x equals negative 12 and negative 4/3. If you squared both sides, you'd eventually get the same answers, but it would be a lot more work and messy, and you'd probably make some mistakes and spend too much time on it. Now, this one, we got to square both sides because it saves us an incredible amount of work. X squared plus 10x plus 25. You got to FOIL it. Greater than x squared minus 4x plus 4. Then we want to solve. Got your, get all your x's on one side. Oh, hey, the x squares go away. That's nice. So now it's a linear inequality. So you could just say, let's get the x's on one side, the numbers on the other side, and say 14x is greater than negative 21. Otherwise, you got to do a line check. But this one worked out kind of nice. X is greater than negative 3/2. Now, I still need interval notation, so it's going to be negative 3/2 to positive infinity. You could do a line check, though. And a lot of times, usually, it does boil down to a line check. Now, here's a couple extra interesting problems. One of them requires a calculator. These don't. So let's find the smallest value of m such that this is true for all x here. So trying to make this true. And we're trying to figure out what's the smallest value of m so this is still true. So we could pick big values of m and it'll be true. I suggest maybe graphing this function. Like, well, what does this graph look like? So it would have x equals negative 3 is a vertical asymptote. 1, 2, 3. Right? X equals negative 3. So this is something we could do without a graphing calculator. But we're specifically looking at the graph over here from 1 to 4. 1, 2, 3, 4. Now, this graph also, as x gets really big, this gets tiny, goes to 0, so it has a horizontal asymptote y equals 0. You can plug some numbers in. If you plug negative 2 in, you get positive 1. You plug negative 1 in, you get 1/2. You plug 0 in, you get 1/3. You plug 1 in, you get 1/4. Plug 2 in, you get 1/5. You plug 3 in, you get 1/6. Plug 4 in, you get 1/7. So the graph is going like this. Okay, but we're specifically looking at this chunk of the graph, and we're saying, what's the biggest value of m where this graph will still be underneath it? Essentially, what's the ceiling? What's the highest point of this graph from 1 to 4? From this part of the graph, it's right there. That's the highest the graph is, which, by the way, is when you plug 1 in. So that's sort of like your upper bound of this function when you're looking at 1 to 4. So m equals 1/4. And I feel like the graph kind of makes that a little more obvious. I'm going to jump to 17 and then we'll come back to 16 as it's a graphing calculator problem. So we're saying for what values of x will this be true? And you might be like, oh, well, all values of x. I mean, it's something squared, and squared don't square roots, undo squareds, and isn't that going to be the same thing? Well, you got to be careful. Let's break it down a simpler problem real quick. Is the square root of a squared always equal to a? Yeah. No, not necessarily. Not necessarily, because here's the deal. If a was negative, let's say if you did negative 3 squared, that would be the square root of positive 9, which would be 3. So does negative 3 equal 3? Nope. So this is only true if the original number was positive. Then yeah, 3 equals 3. Right? Because when you square it, you lose the negative, but you take the square root and you're acting like it is what it originally was. Now that negative, if there was a negative in there, has been erased and doesn't just magically come back. And so this is going to be true when the inside that you're squaring is positive or equal to 0, right? Okay, so now what are the things that make this true? Well, this is a polynomial inequality. Let's do a line check. Let's factor it. Minus 2, minus 4, x equals 2, x equals 4. Line check, solid dots, 2, 4, test a value, x equals 5, true, false, true. So the answer is negative infinity 2 and 4 to positive infinity. So this is true for these values of x only. Now, graph and calculate problem. There's two ways we could do this. We could graph two graphs, which in this problem is simple enough, but on many other problems it's not. So I usually just kind of don't take that approach, but we could go to y and say, okay, well, math num absolute, okay, x to the third plus 2x minus 3, close the parentheses. And then we could graph y equals 5 separately. It's a horizontal line. We can get a window. I mean, I don't really know. Negative 10 to 10. On the tests, they often gave you restraints on what your answer should be considered. There is none this time. Graph it. Now, after the fact, I think I, feel like I could make the graph a little nicer. But so here, let's make the graph a little nicer. Let's go negative 5 to 5 and negative 5. Let's try that. A little closer view of it, which is helpful. Now I need a sketch. So we can draw a sketch. We got this coming in here. We got this, right? And by the way, when you graph absolute values, they have this effect of usually creating very sharp points here. And then we're saying, where's this graph below this other graph? Well, right here, the absolute value one is below the other one, but it's got to be open dots because it's not or equal to. So this is a picture of my answer. And now I just got to figure out, well, what are these intersections here? So on my graph, I could find intersections between graphs. I could do a second calculate, number 5 intersect. You got to choose the curves. First curve, enter. Second curve, enter. Take a guess. Otherwise, it's going to find the one it's closest to. And the closer your guess is, the quicker it finds it. So you're never going to rely on just moving the cursor over. Now, you should be writing more than 3 decimals in your work, especially if it's needed for something else. Second calc, number 5 intersect, first curve, second curve. You could guess by moving the cursor over. You could say, oh, it looks like it's around 2. Just type it in. That's a lot faster if you're not close to it. 1.670244.705. So I want you to sketch the graph, label the stuff on it that you found, and then write your answer. So the answer is going to be negative 0.770, 1.670 parentheses. Now, you could round the first number, 0.771. Second number, round is the same as truncated answer. But what I would suggest, though, probably a better strategy here in general, this one it worked out, it wasn't too fine, is to move everything to one side and graph a single function, which is just less work, and then figure out where that function is below the x-axis, which is much easier to identify. So if I do that on the first problem, I would have I just would have graphed this one function, combined function, and so I graph it, and it looks like this. It looks like the first graph, but shifted down. So you'd sketch that and say, okay, well, it kind of goes like this. And essentially now you're saying, well, where is it below? Where is it negative? Where is it below the x-axis? And that's going to be, here to here. It's this chunk of the graph. So then instead of finding intersections, you're finding x-intercepts. So you do second calculate 0. And you got to tell where to look for it. You're like, well, it looks like it's at -1. So I'm going to say -2 to 0. And I'm going to guess -1. Then I'm going to write on my picture, -0.770917, 0. I'll find the other one, so I can calculate. Number 2, 0. Yeah, it looks like it's like 1.7. Let's go 1 to 2, guess 1.7. 1.6702447, 0. Show your work, write your answer, -0.770 to 1.670. Parentheses, same answer, but I think on this problem it didn't make a huge difference, but usually it makes a huge difference. Do one function. So that's it. Hopefully you're ready for the algebra part of the exam, which was 80 points, so it's a lot of points. That's the one we're going to retake first because that's the quickest way to raise your grade. And grades are coming up.